Good day, folks. This is tutorial number 21 in a playlist that deals with dynamic scenario creation in 3D experience. Now, it's going to be done in two parts. One of them is where I do not apply any material on the part that I create, and that's the way I did it in the last 20 tutorials in this playlist. And then after we sort that out, we come and say, okay, what if we actually applied some material at the part level, and then how do we go about doing the problem? Okay, so initially, we're not going to be applying any material in part design. Now, uh, I'm going to take a very simple geometry, which is a cube. And if the cubes have different dimensions here, then the three mass moment of inertials, principal mass moment of inertials are given by that. But in the event that all the sides are the same, so basically D and H and W are all L, then the mass moment of inertia is going to become ml squared over 6 about these three principal axes. And in the event that L is 1, for example, 1 meter, then this becomes simply m over 6, mass of the block over 6. Okay. There's some other slides here, but we'll come to those later on. Okay. Let me go ahead and make my part. Start with an assembly. Okay. And insert my 3D part. All right, let's go make it. It's a box which is size 1 meter long each. So let me draw a rectangle here and dimension the sides to be 1. Okay, it's also 1. Exit and pad it up by 1 meter. So there's my box. Okay. Notice that I'm not applying any material in the first part of the tutorial. So we go all the way to the top, at the assembly level, and then switch application, mechanical systems design. Now, at the very right-hand side, you see this thing called weight definition. You click on it, okay? Notice that it says 100% missing stuff, okay? Weight definition. That's because I haven't applied any material on it. And that's why this, by the way, is all red. Now, if I click on this, or presumably here, doesn't matter, either there or the part, there are two choices that I have. It says, click this hyperlink to declare a weight on this element, okay? Or the bottom one says, click this hyperlink to compute the weight based on geometry, etc. Let me show you something. First of all, if you go to the bottom one, if you go to this bottom one, you click on it, what it says is that, hey, I don't have any material, so I use default density of 7770, which is pretty much steel, and based on that I calculated the mass, and notice that if you take the mass and divide it by 6, you're going to get IXX, IYY, and IZZ. Great. Okay. Now, if I don't want this, I can close it because I don't have the opportunity to change any of these things. Okay. So if I don't want this thing, I can just use the recycled bin, get rid of it. Okay. Now, let me click on it again. This time, instead of going to the bottom one, which is exactly what I did a minute ago, I go to the top one. It says to declare. I click on it. It doesn't have it. It's not selecting any default stuff, default density. But if I check this box, see that over here? If I check this box, it initializes it using that same density. You click on it, notice that the density that used was actually that 7770. Now, when I do that, I can go and change these things, okay? For example, let me make this thing 100 times smaller. So it's going to be 77.7. So this is my weight. If I do that, these will change accordingly. See, if I let it go, suddenly it was divided by 100. I can go here, for example, and make it 7 point something. So reducing it by a factor of 100, and this is going to become 1.295. Whenever I'm done, I just close this. Okay, let me click on it again. The declared weight is 7.77. You click on it. Okay, can I change this? Yes, I can change it. For example, I can make it 7,770. The problem is that this can be changed, but these are not going to change. These are not going to change. Okay, now if you check on this again, it's going to put everything back to default, initializes. Okay, and of course I can change that. For example, 10 times smaller. These numbers change. Can I change these? See, it won't let you change these. Okay, but if you uncheck that, then it will also allow you to change these for whatever reason. So the moral of the story is that if you don't apply material to your part, then you have to initialize it, and either if you selected the one of these links, it'll do it yourself by itself, or you go and select this checkbox and let it do it. Let me undo this. Try it again one more time. Click on that. The bottom one will actually use the properties of steel. Okay. Now I cannot change these things. Okay. So when I close that, then you can say, okay, it's incomplete. So click on it. It says, can I declare can I declare the replace it basically. Now here, if you check this box, uses properties of steel. Okay. And here you can change things. For example, 100 times smaller, 100 times smaller, it automatically changes these accordingly. All right. And when you're done, just uncheck it and move on. So when it's everything is declared, so blue, when everything is missing is red, and incomplete is half red. Now, this is the case where actually I did not apply any materials on this. So let me do the following. Let me go here, uncheck everything. So there's no material there, and I'm not using this. Let me go back to the part. I'm in part. I can get rid of that. I'm in part design, and let's apply material to this. For example, let's go to, I don't know, we have to go to tools. Here's a material. Let's create a material. I'm going to call it January 8, 2025. And I say, okay. So the template is going to be created, then I'm going to apply it. January 8, 2025. Apply. Let's do this. Apply to that part, 3D part, check mark. Of course, there are no numbers here, but let me go ahead and put some numbers. On the material simulation, this is where you put your Young's modulus and Poisson ratio and density, etc. Let me go on the general option, density, and put a number here. Let's say, I don't know, 10,000 or 1,000 steel, not steel, for example, aluminum. Okay, and then we say, okay, so we have specified the density. No problem. You want to check it? Double click. There's the density. This is where the density was defined, right there. But if you double click on the line above it, so between what it says material simulation and material simulation domain, and the materials over here. Click on this. That pops up, and look at the density. I did specify it to be 1,000, but that is not reflected here. Just keep that in mind. It's going to be important. Okay, so when I double click on this, I don't get my 1,000 here. That's okay. Now, let's go all the way to the top. Go to Mechanical Systems Design. Yep, Mechanical System Design. Notice that my part has a material on it now. We go all the way to the right. Do you remember this? Weight definition. 100% missing, right? But now why is that? If you click on the computed, if you click on the computed weight, you get all zeros. So what happened to that density? It didn't come into the picture. So we say, fine, let's close this. Miss 100% missing. Go back to that material. Go back to the part, basically. Double click on this line. Remember there was a zero at the very bottom? Now we put our number there, 1,000. Yet that 1,000 was already defined, is already there in the material simulation domain, but it was not here. You say, okay, go back to your mechanical system design, and now click on this. Okay, click on that. 100% missing. You click on it. It says click this to compute the weight of this based on its geometry and whatever properties you put in there. Notice that it's not using steel. It is using the value that I put in there. So the key is, if you have your material and you want to specify it, you don't want to use default steel and then go ahead and change things as I did in the first 20 tutorial in this playlist. What you do is you make sure that when you apply material, it's also correctly reflected there. Now the rest is the same as before, so be a little bit careful about how you adjust these things. Now this is the transparency or slide that I was talking about. We specified here, but not there, and that did not help. And I want to remind you that this will initialize, and it initialized based on the properties of aluminum that we put in, not steel. And here is sending things to recycle. Okay, all right, folks. So it's a little bit more than meets the eyes. Unfortunately, not properly documented. All right. Good luck.